inventors are making concrete magic things.
We're moving a lot more towards smart materials.
This high-tech metal takes waterproofing to a new level.
The water will be repelled, can bounce off the surface, just like a basketball.
People are making diamonds and doing it better than Mother Nature.
It's cutting-edge technology, and no pun intended.
In the future, we won't be making things the old-fashioned way. I'm Chuck Pell. I'm an artist, entrepreneur, and futurist, and we'll explore how future tech is rebuilding our world in this edition of Earth 2050. Welcome to Earth 2050. When scientists and historians look back in time, we tend to divide these periods according to the materials that we used at the time. The Stone Age, the Bronze Age, and the Iron Age. It's no coincidence we divide these times according to the materials, the stuff that we use to build our world.
If you look at the history of materials, they're really hints on heroes of human civilization.
Yeah.
Why? Because almost every major advance we've made as a civilization has been pushed forward by an improvement in what we use to make things.
People fly in an airplane where they see a rocket take off. They take for granted the materials that it was built with.
When people think of technological advancement, they think of things like computers and other types of electronics. But just as those things are changing at breakneck speed, the materials we use, the basic building blocks of our world, are changing too.
In the future, what we'll find is extremely durable materials that are lighter, more fuel efficient, potentially even integrated with battery and electric and solar power energy.
And these materials will be smarter. Yes, you heard that right. Inventors right now are developing what are known as smart materials. This is a potential revolution in the science of how things are made.
I would define a smart material as a material that can not only detect the conditions around it, so for humans we're able to detect when we get poked or hurt. A smart material will be able to detect what's happening to it and then adapt.
Where smart materials may have their most immediate effect is in concrete. We don't think about it, but concrete is everywhere. It's the most widely used construction material in the world.
Around 80% of all our engineered materials belongs to concrete.
Concrete has been around since ancient Rome. The Colosseum, built 2,000 years ago, is made largely of concrete and is mostly intact, which tells you a lot about how durable concrete is. Since concrete starts in liquid form, it can be molded into all sorts of shapes, which gives it advantages over lots of other construction materials. We use it for buildings, roads, bridges, sports stadiums, almost everything. That's the good news. The bad news is that concrete doesn't last forever. The Colosseum is still standing, but it's also crumbling. The same thing is happening to the world's infrastructure, which gives a bigger workout on a day-to-day basis than the Colosseum ever did.
We can't currently keep up with the deterioration that's occurring in our infrastructure. And it's a huge drain of time and money.
The crux of the problem with concrete sounds simple. Concrete cracks. And that cracking is trouble for a lot of reasons. Water gets in those cracks, and when water freezes, it expands, which makes those cracks even bigger. Most large structures made of concrete are reinforced with steel supports. That makes for a very strong structure, but when the concrete cracks and the water gets inside, the steel starts to rust. What's the solution? Well, what if concrete got smart and took on some human-like qualities?
Concrete is actually a relatively dumb material, especially if you compare that with biological materials such as my hand, for example. My hand can do a lot of different things that concrete cannot do.
Like healing itself when it cracks. Now that would be a different kind of building material. This This is a piece of concrete being stressed almost to the breaking point. Clearly, this is in a laboratory situation where no one can get hurt. But when this happens out of the lab, say in an earthquake, it can be disastrous. That's why scientists have engineered a new type of concrete called ECC, which stands for Engineered Cementitious Composite, which is a technical way of saying that they've created concrete that's flexible under pressure.
So when you see ECC bending, it's not so much that the material is bending itself, but many small cracks are opening up in the material.
If this were old-fashioned concrete, the cracks created by this bending would make the concrete weaker and weaker, and that's dangerous. But ECC concrete contains materials that heal these cracks before they open up and become the kind of gap that can result in permanent structural damage. That's why it's sometimes called self-healing concrete.
Right now, in concrete cracks, if you want to do anything about it, you have to send out a maintenance crew. That requires time, effort, money, basically just a lot of hassle. Whereas self-healing concrete, if concrete's damaged, then it can just self-repair itself without any outside intervention.
Think of it like this fork. If you apply a little force, it'll bend quite a bit. So the idea is, if you can build concrete with a little more flexibility, now you get a much safer building material.
This works because ECC concrete has larger concentrations of calcium carbonate and calcium hydroxide, substances found in seashells, in the mix. When small cracks form in concrete, these materials come to the rescue.
Basically, self-healing concrete works when it's exposed to just water and air. So if you're using it outside, it only needs precipitation, such as rain or snow, in order to heal itself.
The rain, or any source of water, rehydrates the materials in the concrete, creating new fibers. And once they're activated, these fibers start growing, essentially stitching themselves together and closing the wound.
The sciences that we are using comes from basic fundamental physics, chemistry, and biology.
It's very similar to what happens to your finger if you get a paper cut. It heals itself before the cut opens wider, before it opens so wide that you could be subject to infection and further damage.
So the advantages of ECC are that it's more durable and more resilient than normal concrete.
This computer model uses color codes to show what happens when a test slab of concrete is being pushed to the breaking point. Each crack is recorded and monitored.
And the computer program can then calculate and detect where the cracks are occurring. So as you see this video cycling through, you can see a lot of new cracks appearing, and that's what happens as we're loading it, more and more cracks appear.
These cracks are generally no more than 50 microns across. That's the width of just one of the hairs on your head. That makes the cracks easier to heal.
It's more resilient, not just because it can heal itself, but also because it reduces the probability of failure, it reduces the consequences of failure.
This kind of concrete is already being used in buildings around the world, particularly in a place like Tokyo that is very prone to earthquakes. By 2050, this will likely be a feature in many projects using concrete. That will not only save a lot of money, it's going to mean greater safety for millions of people around the world. Diamond. They're beautiful and they're unique. They are the hardest naturally occurring substance on Earth. And that's made them extraordinarily valuable. Worldwide, the market for diamond jewelry is more than $60 billion a year. But only a fraction of the diamonds that come out of the ground find their way into rings and necklaces.
But only take the really good diamonds and make them into jewelry.
Imperfect diamonds, about 80% of what are mined each year, are used by dozens of industries. Their hardness makes them ideal to cut and polish surfaces. Diamonds are so valuable and so useful that we human beings decided to bypass Mother Nature and make them ourselves.
Before we take a look at how we make diamonds, let's see how Mother Nature does it. The carbon that forms diamonds is one of the most abundant elements in the entire universe. Every living thing is made out of carbon.
It's just a material that's quite abundant. It's in all the plants and animals and stuff.
Today's children are tomorrow's global citizens. Nurture our next generation of leaders by building a solid foundation for their futures. Through encouragement and inspiration, equip them with the skills and knowledge to succeed in tomorrow's complex world. Delia School of Canada, providing primary and secondary students with a world-class education in Hong Kong for over 20 years. Delia School of Canada, putting education first.
All of this. Are those sure pansies? Saving the world. Oh no! There's a leak in the boat! There's no picnic. We have to shut down the machine before the food animals get off the island and invade the mainland. Isn't it? Tonight, cloudy for the Jackson and Falls too. On Barrow's weekend blockbuster. The capital of Yemen is under closer to collapse, coming as soon as tomorrow.
This red dot in the eye is trying to give us a location. When those lights go black, we're gonna disappear from this place like ghosts. Let's go. We can't find these. Getting over that wall is just a start. Hurry.
Are there cheaper investment opportunities besides the AI stocks? In the last 2 years, the US
Bigger telescopes planned on Earth may help, but there's nothing like being there and capturing close-up images. And it's very unlikely that we will see another probe visit Pluto. Side. It is not just Pluto where this phenomenon has been observed either. On Mars or Jupiter's moon Europa, for example, evidence of collisions from asteroids or comets can be seen. The scars of seismic waves racing through and
信樂為你照顧更周全，信樂相信醫療保險本應如此，信樂真係同路人，請即致電81079155或上網了解更多。雖然媽咪梗係想寶寶吸收天然營養，健康成長。荷蘭美素佳怡保存每年牛奶嘅天然營養，純牛奶製造，新鮮直送，適溫處理，源於天然。匯萃多元，保存天然營養，消化輕鬆好輕時。荷蘭美素佳怡，屬於你同屋企人嘅非凡旅程，由呢刻開始，一齊登上國際級海上度假村，盡全投入刺激水上派對，親身感受極上嘅5星級服務，輕鬆嘆盡全球美食，與摯愛一齊欣賞令你目不暇給嘅精彩表演。海洋航行者號、海洋讚禮號從香港雙輪出航，把握限時優惠，立即報名。非凡體驗盡在皇家加勒比。斯曼尼梳化可能係你見過最多顏色嘅梳化，仲有過百款設計。咩原因？斯曼尼梳化限時禮遇，全場梳化8.5折 ，VIP 再減5%，再送歐圖按摩禮品，價值高達4900，仲快啲嚟揀下！是禮梗係芝麻嚟。Penguins, whales, dolphins, sheep, ancient trees, and its most distinctive bird make their homes in this spectacular place. Tuesday, Wild New Zealand, at 9:35 on Pearl Spectacular. Coal is similar to diamonds in chemical structure. But here's one difference. While coal is formed just a few miles below the Earth's surface, diamonds are formed much further down, up to 100 miles further down. You go down that far and the temperatures get really hot, close to 4,000 degrees Fahrenheit. And being under all that rock makes for some incredible pressure. That's a perfect combination for the Earth to make diamonds.
Basically, you need high pressure and high temperature, and carbon will convert to the diamond phase.
Diamonds are so pure in their chemical makeup that they are the ideal substance to move energy efficiently. This is called thermal conductivity, and it has the potential to save billions of dollars in energy costs.
The diamond is better than other materials because it is the best conductor of heat known to man.
jewelry. But for use in electronics, these diamond makers sometimes want to add impurities to affect how much the diamond can conduct electricity. In what is essentially a diamond factory, they can control the process from start to finish. It's sort of like cooking at very high temperatures.
Right here is a microwave cavity, so we bring in microwave energy that comes in this way, and we basically create a very special environment there to grow the diamond. You can see the hot plasma growing, that's going to grow the diamond. It's kind of glowing a purple color right now.
Once these diamonds are grown, they undergo a process similar to diamonds used in jewelry. They're cut, in this case with lasers, not to make them more beautiful, but to make them a more efficient industrial tool.
Right now we've got a diamond that we drew right here in the lab, and we're framing it, which means that we're going around with the laser and cutting out the unwanted material that grows around the edge of the diamond. It forms a rim as it grows up, and we have to cut that away before we polish it to get a nice optically clear crystal.
That clear crystal can be very effective, no matter what its size. Here, a tiny glass-based device is being tested to see how well it conducts electricity.
This dimension here is about the length of a grain of rice. It's very, very small. And there's about 100 devices that I can test on that single device. Each one of these is what's called a diode. And that's a very simple electronic device that controls the flow of electricity. It either allows electricity to pass or blocks it from passing through the device.
By 2050, the ability to make larger industrial diamonds at much less cost than natural diamonds will mean that this material will be used in all sorts of machines. Almost anything that's powered by electricity, which is practically everything, will work better and be much smaller as a result of this technology.
The biggest applications for this technology is going to be alternative energy. So things such as electric cars, solar power systems, alternative lighting, LED lighting, efficient lighting.
These man-made diamonds are just one more example of how nature can inspire design innovation that can transform our lives. After all, diamonds are billions of years old, but they're still a stepping stone on the road to 2050.
Welcome back to Earth 2050. It's only been in the last 300,000 years or so that human beings have been making sophisticated tools. And it's only been in about the last 8,000 years that we've been making really good use of metal. And when you think about it, that's almost no time at all.
Steel, a truly revolutionary material, has only been around for about 2,000 years. It didn't come into widespread use until 150 years ago, and that changed everything.
Steel is almost a wonder material. When you go and you look at what kind of transformation occurred for us in the middle of the 1800s when steel suddenly got cheap and easy to produce. We had skyscrapers, we had everything we made out of steel.
Steel is not only used to make and support buildings, planes, trains, cars, and even our spaceships rely on steel. It's strong stuff, but it has one relentless enemy that seems to be anything but strong. Water is to steel what kryptonite is to Superman.
If you put a water on metal, it create many detrimental effects, especially for corrosion, rust, formation. It's precisely because the water content on the metal surface.
It sounds strange, but water is actually kind of sticky. This stickiness is called surface tension, and water has quite a lot of it. So when rain falls or dew forms on an airplane or a car, surface tension is why water beads up instead of just rolling off. After a while, that makes for a lot of rust and ultimately a lot of decay.
So if we can eliminate water, like metal will last longer and be more robust.
Being able to make metal more durable and more resistant to water could transform how we build things. That's why scientists at the University of Rochester have come up with this. It's called hydrophobic metal, which literally translates as metal that's afraid of water. This makes sense because when water hits this kind of surface, it bounces off, like a basketball off a hardwood floor.
We make the surface become super water repellent, and the water would not be able to stick on the surface.
If you look at hydrophobic metal with the naked eye, it looks like any other metal. But under a high-powered microscope, there are thousands of little bumps, like tiny clouds or mountain ranges. And that's what causes water to bounce off this surface. Getting metal to act this way is one complicated process. The metal is hit with laser light in very short, very powerful bursts of concentrated energy.
Just packed with enormous amount of intensity.
There are all sorts of potential uses for this technology. De-icing planes could become a thing of the past, since ice would never have time to form. With the surface tension problem eliminated, ships could move through water more easily. Machines and buildings wouldn't rust. They could last almost indefinitely, a major money saver.
I think the super hydrophobic actually has more application than I could originally possibly imagine.
The only drawback with this tech is that, at least right now, it's very time-consuming and expensive to treat metal with lasers. It can take hours to treat a piece of metal the size of a postage stamp. But soon, that problem will be solved. Not only will many machines and vehicles be made out of hydrophobic metal, it will even be used in drought situations. If water runs off of a metal surface and is collected, none of it evaporates. The larger the surface, the more water that's collected. Even better, if water doesn't sit still, it doesn't have time to react with the sun. And that means there's no time for bacteria, some of it deadly, to form in the water. The Bill and Melinda Gates Foundation has looked at this technology to build self-cleaning bathrooms in developing countries. An idea that could change the lives of untold millions. All because metal, something most of us don't spend much time thinking about, is one technology being transformed by even better technology as we approach 2050. Diamonds, concrete, and steel. Things that we've been using for centuries. And they haven't changed much until now. The next decade will see such a change in our basic building block materials, it will absolutely transform the way we live.
I have come to the conclusion that what we need to do is we need to take a long-term view and we need to work on materials. When we were in the Stone Age, we colonized and settled every continent except Antarctica. And that includes the Pacific Islands. The Pacific Islanders are moving out in those wood canoes were in the Stone Age when they settled those islands. Then you jump to the civilizations that used like bronze, then the Iron Age, which was near the end of the Roman Empire. I mean, these were big changes in society. People could do everything more efficiently with better, stronger materials.
As we move to the year 2050, there's going to be lots of new materials invented, giving you a lot more capability to actually design the material you want for a particular application using these computational tools being developed. So I think designing the material or the layers of material you want will become a standard design process as we move to 2050.
We're moving a lot more towards materials that are able to not only detect what's happening to them, but also adapt and be able to kind of mitigate the problems. So over the next 5, 10, 15 years, I expect smart materials are going to become a lot more popular.
It's really satisfying to grow a diamond in-house and then to be able to shape it and polish it and end up with a clear diamond crystal. It's definitely very satisfying, very gratifying, definitely huge potential for the future.
Even outer space is playing a role in the future of the materials we use. Right now, tech entrepreneurs are actively preparing to mine billions of tons of water ice and platinum group metals from the near-Earth asteroids. The first stage of that technology is already in space, and we'll be covering that story for you on another edition of Earth 2050. I'm Chuck Pell, and I hope you'll join us out here.